and the other friends who has invited me, first of all, that this is my second visit to Morocco. And what I would like to talk, my apology for being late because my flight was delayed. I arrived actually 4 o'clock in the morning, so I barely woke up. So what we're going to discuss is what we understand in terms of diabetes, genetics, ethnicity, lifestyle, because all these factors are influencing that what I will go through some of these issues and try to see. What we understand, if you look at this natural history of diabetes, then we have this genetic susceptibility, which we all agree, that probably this could have an effect on your obesity and also insulin resistance, and also to develop the metabolic syndrome, where the onset of diabetes is determining, because if you look at the Indians, that we see that our onset of diabetes in Indian population is by the time they are reaching 40 years of age, they have the equal risk of 60 years old man from Caucasian ethnicity. So there is definitely, and then we're coming to its complications. And we have atherosclerosis, you have retinopathy, we have blindness, and disability and death. So we know this natural history, and I will go through some of the issues that actually what influences these complicated issues. First of all, we need to think of the environmental or intrauterine life, the risk, or sometimes we call the fetal programming, and which was Barker was the initiator, and let's say that we start from there, because we always discuss that where should we start? If we are thinking of in terms of our prevention, where do we start? And then we said that, okay, should we start here? Because we said that we should start before the onset of diabetes. And then when the diabetes actually, the programming starts, that's the kind of discussions that I would like to take here. And here you have the fetal hormonal nutritional milieu, and glucocorticoids, insulin, and insulin-like glucose factor, and other maternal factors like malnutrition, stress, and disease. And actually what we are talking about is what we are saying that these are the factors that influences the gene, the genetic and predisposition, because what we are moving to is the epigenetics. Epigenetics actually is nothing other than the lifestyle, because the lifestyle is actually changing the expression of the genes for the development of the disease. So when you talk about lifestyle, actually you are talking about epigenetics. And then comes the fetal growth, and also the programming, and the birth injuries, and then you have the life course, of course. Then you say, so there generally we start the intervention during the life course, and which is often delayed. And this brings us to the family's lifestyle, socioeconomic status, education, training, and the family-owned healthcare behaviors, and the adult health. But we see that there is a big difference here. When we are talking about the fetal growth, we often talk about the malnutrition and low birth weight. This low birth weight is actually, we are saying that what we are seeing in India, it is actually, we are not seeing any effect of malnutrition in pregnancy in relation to delivering the low birth weight babies. And this is something that we need to think, because I think that for the population that we are talking about, that we are, in my understanding, we are misclassifying those who are actually at risk, that is those who are low birth weight, real low birth weight, and increased risk for cardiometabolic risk, and those who are not. 2,500 grams, it seems to be in Asian population, or Indian Asian population, seems to be inappropriate. We are coming closer to 2,350 about. So, and this we need to examine for every population. Otherwise, we'll see that the effect that they're showing in the Caucasians, we are not finding the same associations in the Asians. This doesn't necessarily mean that nutrition doesn't have any effect, but it simply means that we are misclassifying the people. And then we have the genetic factors that we have seen that if you look at this picture on the right-hand side, if you see this, for example, offspring of type 2 diabetes and subjects, and if you look at the insulin sensitivity and the ideal body weight, you see that when the body weight increases, the sensitivity decreases. And if you look at the control population with the control population, but we see that this, I will go back here, and this I will show you that those who have a family predisposition, they are at a different stage compared to those who are coming from normal families. And if you see the differences that we see between the controls and the offspring of type 2 diabetes is actually, we are talking about the impact of the genetic factors. But if you look at the impact of the diabetogenesis or obesity induced insulin resistance, you see that it equals, the lifestyle actually equals the increased risk for your genetic predisposition. And then what genetic determinants and the molecular pathways in the pathogenesis? We know that adverse intrauterine environment that we have just talked, and we have also just barely mentioned the epigenetics, and we have the genetic shared environment. And that brings us to the family history, and this also brings us to the altered gene and protein expression, where we are talking about the epigenetics, and which is lifestyle. And cultural, nutrient, and energy excess, this is the lifestyle is actually, you see that when we are talking about this, that excess energy and mitochondrial dysfunction which is actually inducing the obesity is actually also affecting the altered gene protein expression, which will affect our insulin resistance, beta cell dysfunction, and type 2 diabetes. We have identified a number of genetic polymorphism or candidate genes with little certainty. If you look at these risk factors, we see that the risk factors are still, that is actually is not around 1.4, 1.5, it's generally less than 2. And the most important that when we are looking at the candidate genes in different population, we are not finding the same genetic markers in different populations. That makes us a puzzle, because that means that the gene alone is not giving the disease, but the gene together with the other expressive factor, other environmental conditions, is actually giving the expression, and therefore we do not see the same candidate genes responsible for the development of disease in different populations. And then if you look at a kind of a systematic epidemiological approach, if you look at the exposome and the genome, if you look at this, the way that you can see there are some red points, the red bullets, and the green bullets. You see that obesity, diabetes in pregnancy, smoking, and disturbed sleep, which is, and then in some studies, they are showing that, for example, coffee can have a protective effect, healthy diet will have a protective effect, medication. So you see that our exposome is continuously affecting our genetic predisposition. And then we have the genome, which is epigenome, and its transcription to proteinome, metabolism, and metagenome. So all these factors are affecting. We have this basic factor that we are born with, and then there comes the exposome that actually is influencing to develop for the expression of the genetic predisposition. So then we have in brief, we have talked about the genetic variants. We have the heritable epigenetics, and we have DNA methylation. And then what is falling in the middle is the obesity, aging, unhealthy diet, physical inactivity, and which is developing the type. So there is an interplay. There is an interplay between those two. I'm not saying that genetic predisposition is not important, but what I'm trying to say that with our lifestyle, we can change the expression of the gene for the development of the diabetes. And I will come back to, if you look at this, for example, this case, and if you see the genetic risk scores, that 1, 2, 3, 4, and you look at this lifestyle with the placebo and lifestyle intervention, you see that this trial has shown that the effect of genetic risk, genetically predisposed, is decreased if we have the proper lifestyle intervention. And that's what we should think. So in brief, what we're trying to say, that when we are talking about type 2 diabetes, we have the genetic factors. We cannot deny it is there. Other than there are some monogenic diabetes, which would be different than the polygenic. I'm talking mainly on type 2, which is a polygenic. So that's what I said, the type 2 diabetes in the middle. Then you have the increasing age, we have the central obesity, we have the physical inactivity, we have diet, and gestational diabetes. All these factors are is hanging together with type 2 diabetes. And then I'm coming back a little bit towards the diabetes in Asia. And if we look at this homoinsulin resistance and the insulin resistance in different, for example, the South Asians, whites, the African Americans, Latinos, and the Chinese. And you see that at the end, the South Asians, that we have a distinctly different insulin resistance compared to the other races. So the Asians, we are different. But we should keep also in mind, keep in mind that Asians are not only one, Asians are also have sub-classifications. I will come back to that. If you look at this, again, the South Asians, you see given at any BMI, the Asians have the highest risk for the development of diabetes. So that means that it is not only the obesity, but our genetical predisposition is different compared to the genetical predisposition in other, where it makes us more susceptible to obesity. So if you look at this type 2 diabetes in immigrants in South Asia, so what we see that progression to diabetes in the immigrant, in the South Asians, that we say that's about 12 to 18%, whereas the progression to diabetes to the ethnic Europeans was about 5 to 11%. So what we see that there is a difference between 5 to 10 years. The development of type 2 diabetes between those two, even though you give an intervention, there is a difference of 5 to 10 years. Then what we need to do, we need to start at an earlier or more intensive lifestyle intervention needed for the Asians compared to the Caucasians. And then when the obesity is increasing, it is also quite interesting to see that actually the obesity actually hits at the earlier stage of our lifetime. When we become, let's say, 60 and above, actually obesity doesn't matter much. So we need to intervene earlier because the obesity in the earlier stage seems to affect more compared to the obesity that is coming with their age, for example, when we are more than 60 years of age. So this is more or less you see that the obesity effect remains mainly with the younger age group. And how much is the race or ethnicity versus the behavior? We say that there is one study that is done, and where we have taken adjusting for age and family history, which we use as a base model. And then we looked at the risk by, for example, base model plus education, base model plus behaviors, and active smoking, base model for body characteristics, and base model for behavior plus body characteristics. If we say that, you see that there is an increased excess risk to the contributing factors from 13.5% to 47.8%, that it actually increases. And then this has also been drawn, if you look at this modification of the genetics, that if you look at the first on the top, on the polymorphism, that what we see the differences is the TT variants. It is the TT variants that is different from the control population. But when we do the lifestyle, if you look at the slides below, then we see that with the lifestyle differences, we see that TT variants is brought to the similar level in the intervention population. So that means that even the genetical modifications can be done, through its expression, equivalent to those who are normal or without risk. So this is also a kind of ROC curve that is the conventional risk factors where we are looking at age, sex, body mass index, family history of diabetes, smoking, and alcohol intake. So we put a GRS or genetic risk score, and we look at the areas under curve. And if you look at the conventional risk and conventional plus GRS, the so-called genetic risk score, you see there is no difference. It is now made equal. So that means that what we are trying to say that in our understanding that we need to say that the biggest problem in the medical community is that we don't think that the intervention or the prevention is our task. Treatment is our task. I think we have to move from there, that actually prevention is the treatment for the people with diabetes, because when you have diabetes, until now we don't have any cure. So we need to think this way. So what are the learning points that we're coming up because of the time constraint? I'm saying that type 2 diabetes is a common chronic disease with high individual and social cost, that we all agree. And behavioral, cultural, genetic, and environmental factors all contribute to diabetes risk and diabetes disparities. Family histories can be a valuable tool because it provides an insight into the behavioral, cultural, genetic, and environmental factors that it determines the diabetes, and can be used to promote prevention and management. So we can start, for example, if you look at the high-risk population, this could be an interesting way. And with advances in genomic technology, large number of specific genes polymorphism are being associated with type 2 diabetes. And we are identifying more and more. But genetics of diabetes are complex, and each polymorphism carries only a modest increase in relative risk, which we have seen. The environment may affect diabetes risk directly through the behaviors. And lifestyle modification can prevent diabetes or delay its incidence, including the treatment outcomes, even in those with a biological risk. And in conclusion, what we say, the feto-maternal environment and inheritance is different in Asians compared to the Caucasians. That we should think. And therefore, I would ask, for example, do we know exactly that what we are trying to do in Asia, in the Asian Indian subjects, to identify what should be the ideal weight gain during pregnancy? Because we think that this is related, because if you look at all the studies that was done, the mean birth weight of children by race, it seems that the Asians have lower birth weight compared to the others. Also in Asians, for example, if you look at the Vietnamese, for example, they have the lowest level of birth weight compared to even among the Asians. But they have the lowest risk for the development of diabetes. So low birth weight is not necessarily always associated with if we identify that which low risk is actually increasing the risk for cardiometabolic risk. And that is the job of our scientific community. And we must diminish fetal-maternal body fat percentages in the offspring by identifying proper pregnancy weight gain. Because what we are seeing that in the Indian population, you probably have heard the story of thin, fat babies. This, because we see that because of the extra feeding that we are giving in order to catch the growth, both during pregnancy and in their childhood, that we are actually increasing the body fat percentages in the children, which is, even though they are not overweight compared to the others, but they are more body fat percentages because they are not supposed to have the equal weight gain in their early life. And infant food and food behavior, including open access to healthcare, even under economic constraint, to screening and treatment programs, and to develop educational programs to specific cultures are needed. So with these words, I would like to thank you for giving me the time, and we hope that we can come back to discussions if there is any. Thank you.